the ventricle will contract. Okay, now it's really squeezing. As soon as the pressure in the artery is greater than the artery, so as soon as it squeezes, the pressure here, of course, is stronger than here, and the valve will open. The semilunar valve will open. This is called ventricular ejection, and it's also called stroke volume. Okay, so this part is right there. But so now the ventricle now will relax again. Okay, ventricle are now ready to repolarize. So when the ventricle is repolarizing, okay, now the atrium is getting ready to squeeze, right? Okay. So when the ventricle is now relaxed, it's represented by the T wave. Okay. But then it's getting ready to contract again. As the ventricle relaxes, pressure will drop, semilunar valve will close, means there's no more blood can leave, and the volume of the blood remain in the ventricle is known as end systolic volume. So after it squeeze, everything is out. There's nothing left to squeeze. There's a little bit of blood left. This is called end systolic volume. Okay. Okay, let's look at this chart one more time. So this chart is the same as the other chart, okay? So starts here, blood start going in here in the atrium, start filling it up. Once this is filled up enough, it's going to push the valves open, all right? And then now it starts squeezing. All right, start squeezing all the blood into the ventricle. Now it start filling up, okay? It start filling up. When it reaches the end diastolic volume, like you can't fill up any more blood, end diastolic volume, it will start squeezing. Okay, squeezing. This is called ejection volume, okay, or stroke volume right there. It will eject. Okay, that is the force. And whatever is left over is the end systolic volume. Okay, there's no more. Squeeze everything out. And once again, it starts again, filling up the top. As the ventricle diastole continue, so as the ventricle relax continue, pressure will decrease in the ventricle until it is less than the atrium, which means the AV valve will open again. So this you just have to visualize, okay? All four chambers are in diastole, and the AV valve are open with the semilunar valve closed. So here's everything together in a flat chart like this, okay? So here is when the atrium is relaxed, okay? Then the atrium will squeeze, okay? Remember, at the same time when the atrium is squeezing, the ventricle is relaxed. Now here, the QRS complex is when the ventricle will start squeezing, okay, causing this to eject all the blood to leave. But when the ventricle squeezes, the atrium is relaxed. Okay, here is both. After the squeeze, it will relax until it's ready to squeeze again. Okay, so if you look at them separately, the ventricle relax here, then squeeze here. After it squeeze, it relaxes. The atrium relax, squeeze here, and relax, and come back, and squeeze here, and relax. Heart sound. Now you guys all have heard lub-dub, 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 okay? Lub is when the AV valve, just imagine what the AV valve is, okay? AV valve, beginning of the ventricular systole. So lub is when it starts to squeeze. Okay. Dub, when the semilunar valve, beginning of the ventricle, diastole. So dub is when it's done squeezing. Okay. Now the ventricle is now relaxed, stopping the blood from coming back to the ventricle. That's when the semilunar valve will close. So lub is squeeze when the AV valves are open. Dub is when the AV valve closes. Okay. When the beginning of the ventricular, when you start relaxing. Okay. All right, that's first part of the heart section. All right, let's review a little bit. QRS complex is when the ventricle squeezes, okay, which is systole. Okay, and the atrium, when it closes, it's the P wave. When it squeezes, it's the end of the P wave, and then it relaxes. And the T wave is the beginning of the ventricular relaxation. And the heart sound, lub-dub. Just want to note that the sound comes from both of them closing of the valve. When the first one squeezes, when the ventricle squeezes, it will close the AV valve so that it will go into the semilunar valve will then open. Now after squeezing, the valve will close. Okay, so that's the sound of the dub. So now we're going to see all these numbers again. Stroke volume. Okay, we saw stroke volume thing up here. Stroke volume is when a ventricular ejection is how the amount of blood leaves the ventricle. Okay, the volume of the blood pumped out by one ventricle in a beat. Okay, stroke volume, how much it is squeezed out. Heart rate is contraction per minute. The amount of blood pumped out of each ventricle in 1 minute is called the cardiac output. Okay, the amount of blood pumped out by a ventricle is called cardiac output. The formula is heart rate by stroke volume. What is your heartbeat and how much blood is pumped out. Resting versus exercise. So the heartbeat is based on neuronal, which is your nerves, hormonal, and other environmental factor. Okay, your nervous system affected, your age, fitness level, things that affect the stroke volume, which is how much it squeezes out, your heart size, your fitness level, gender, and all that stuff. Okay, so here's what the heart, how much blood is pumped out, heart rate by stroke volume. Usually this is the range. And here's the range of the cardiac output. Now remember this, okay, maximum is 150, okay, which is the heart rate, maximum heart rate 150, maximum stroke volumes, how much blood is squeezed out, 130 milliliter, okay. We don't want to go over 150 because when you reach about 160, your risk of the stroke volume decrease to the point of cardiac output falls, and then you have heart failure. Okay. Here's the target rate, a heart rate to maintain, about 120 to 160 when you're exercising. Cardiac center in the brain. Heart rate is affected by the parasympathetic and the sympathetic nervous system. Para means slow down, okay, slow down. This will slow it down. Sympathetic will accelerate it, okay. And it's in the medulla, cardiac center. That's why if you get hit in the neck, you might have a your heart might stop beating. Okay. So if there's an increase in the parasympathetic, the heart rate will decrease. If you have an increase in the sympathetic, your heart rate will increase. So just like how I said here, parasympathetic means slows down. Sympathetic, it is raise it up. Increase heart rate and force of contraction. So there are a lot of things that could increase heart rate. Okay, one of them we talked about, a chemoreceptor. It detects the oxygen and hydrogen level and carbon dioxide. The baroreceptor, when it detects, what it detects is the blood pressure going through that the blood vessel. Okay, it can detect how much blood is going through. So a lot of times, like if we stand up too fast, okay, your baroreceptor is not able to catch up, and it sends a decreased blood volume or blood pressure, and then it will, it will cause your blood pressure to increase. Same thing as the other chart. Okay, stroke volume, how much blood is squeezed out. There's also a formula, okay, is the end diastolic volume minus the end systolic volume. So what does that mean? Whatever is filled in, okay, let's say you filled